Hello and welcome to Crazy Math Productions. Today we're going to be looking at a new unit that we're going to be doing. We're looking at different exponents, positive, negative, zero exponents, applications in scientific notation. So we're going to go through and we're going to look, first of all, just some basics here. X is called the base, Y is the exponent, and the entire thing is called a power. Now, first we're going to look at multiplication properties of exponents. Now, there's several ways you can think of this. Number one, remember that p to the third power, that means that there's 1, 2, 3 p's, times p to the fourth power, so that's 1, 2, 3, 4 p's. So I have 1, 2, 3, 4, 5, 6, 7, so that is p to the seventh power. Now, some people will think that there's a 0 here. Well, no, think about it. There is one x there. So you could think of that as x to the first power. There's also 1, 2, 3, 4 x's there. So that's 1, 2, 3, 4, 5 x's. So that's x to the fifth power. And be very, very careful here. This is when you have the exponent and then you have parentheses here. That means it's like a Xerox copying machine. Copy exactly what you see in those parentheses 2 times. So I'm going to copy 1, 2. Now we also have the same thing here. We have the parentheses and then the exponent right after the parentheses. So that means make Xerox copy 3 times of exactly what you see inside. 1, 2, 3. And you can see, remember we have the little stupid chart here. A positive times a negative is a negative times positive, negative times negative, positive. So a negative times a negative is a positive, so that makes a positive. Negative times negative is a positive, and then you have one negative left over, so that makes the whole thing just negative. Now, again, we don't know what's represented by x. We're not sure if x is positive or negative, but we can know it's going to be the opposite of whatever this ends up to be. So just one negative left over. And then we have 1, 2, 3, 4, 5 x's. So the opposite of x to the fifth. Okay, same thing here. We have parentheses and then the exponent right outside. This is negative 3 to the third. And then we have the negative 3 to the fourth. Exact carbon copies. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7 threes. Now we have 1, 2 negatives, that makes a positive. Negative times negative, positive. Another pair of negatives, that makes a positive. Another pair, that makes a positive. 1 left over. Now we do know we're dealing with 3, so this will make the whole thing negative. So this is 3 to the 1, 2, 3, 4, 5, 6, 7th power. And that will do. You could also try to actually do 3 to the 7th power. Excuse me. No. When people do 3 to the 7th power, one common mistake, excuse me, 3 times 3, you have to count that twice. So that's 2 threes. That'd be 9. And then times 3, that's 3 threes so far, would be 27. Times 3 is 81. That's 4 threes. 1, 2, 3, 4. Times 3 again. It's 243. Times 3 again. That's 5. 729. And we've got 2 more to go. Times 3. 2,187. That's 6 threes. Times 3 again. It's going to be 7 threes. 6,561. For the sake of the notes, though, we could just leave it as negative 3 to the 7th. Okay, again, we have the parentheses here. That means exact carbon copies. Negative 3 to the third. So 1, 2, 3. And then we have 5 more negative 3s. 1, 2, 3, 4, 5. Now, 2 negatives makes a positive, so 1 pair, 2 pair, 3 pair, 4 pair. You notice since we had 1, 2, 3, 4, 5, 6, 7, 8, since there's 8 of them, that's an even number of exponents, or an even number of negatives, excuse me. So since there's an even number of negatives, it will come out positive. So positive 3 to the 8th power. Okay, now there's a big difference between number 5 and number 6. And let me go off screen a second. Let me show you something. This is going to be odd, but if you will look, negative 3 to the third power, the opposite of 3 to the third, versus negative 3 in parentheses to the third, there's a difference here. And let me also show you negative 3 to the fourth versus negative 3 in parentheses to the fourth. What's happening here is a matter of order of operations. Here it says we have parentheses, so make 3 identical copies of negative 3's. 1, 2, 3. Now there's 1, 2, 3 negatives, makes the whole thing negative since it's an odd number. That makes it positive, and then positive times negative is a negative. And 3 times 3, 9 times 3, 27. Over here, it may sound strange, but this is actually the opposite of 3 to the third. Since there are not parentheses, you're simply going to do the opposite, or negative 1 times 3 3's. So there's only 1 negative here, whereas here there were 3 negatives. Now, 3 times 3 is 9 times 3 is 27. 27 times negative 1 is negative 27. Did it make a difference here? No. But let's look at what happens when we have a positive, an even exponent. So with an even exponent, this is the opposite of. So in this one we have, again, just the 1 negative and 4 3's. So 3 times 3, 9, times 3, 27, times 3 again, 81. And negative 1 times all that is negative 81. But here we have 1, 2, 3, 4 negatives. So negative times negative positive, negative times negative positive, or you could just see that it's an even number, where here it's an odd number. If it's an even number, we're going to end up with a positive. So again, same thing, 81, but this time it's a positive 81 instead of a negative 81. So this little diagram here could sort of help you navigate what's going on. If you just have the negative out front with no parentheses, it will be negative. Of course, unless there's another negative somewhere else in the picture. This diagram this way, and that will be negative. If you see it with the parentheses there, then you're repeating. There's more than 1 negative that's involved. Just for practice, just tell me how many negatives here. There are 5 negatives, which leaves the whole thing negative because it's an odd number. How many negatives here? There are 2 negatives. Excuse me, there's 1 negative because it's not in parentheses. There's just the 1 negative. How many negatives here? Again, just the 1 because it's not in parentheses. How many negatives here? There are 4 negatives because it is in parentheses. So this little part of the video you may need to repeat a few times. This is a very, very important part of this lesson that really tends to confuse students. So be careful with this. Okay, so number 6 here, we have negative 1. There's only 1 negative in this part. and 3 threes. Zoom in a little bit, kind of hard to see. So 1 negative, 3 threes, 1 negative, and 4 threes. So negative times negative is a positive. And then we have 1, 2, 3, 4, 5, 6, 7 threes. I'm just going to leave it as 3 to the 7. Okay, here there are how many negatives? Just this part. 1 negative. And there are 4 twos. In this part, how many negatives? Well, there's still just 1 because it's not in parentheses. Followed by 5 twos. Now, negative times negative is a positive, and then we can count the number of twos: 1, 2, 3, 4, 5, 6, 7, 8, 9. Or you can just add those up: 4 plus 5, 9. So that is a positive 2 to the 9th power. All right, number 8. How many negatives are here? Well, it's just 1. And we have 1, 2, 3, 4 x's. Again, we also have 1, 2, 3, 4, 5, 6, 7 x's. All in all, we have 1 negative, which makes the whole thing negative, or the opposite of whatever x would be. And then 4 plus 7, 11 x's. And there we go. Now we have power of a power. That's what happens when you raise this power to another power. We got to think about it. I had said earlier, when you have that exponent right outside of parentheses, you're going to make a carbon copy of exactly what's inside. So there are 6 of these. I'm just going to clone these suckers. And now you can see 3, 6, 9, 12, 15, 18. Well, if that reminded you of something, that's a good sign. What I was doing was skip counting. 3, 6, 9, 12, 15, 18. Skip counting is another form of repeated addition or multiplication. So what you can do with this is you can simply multiply 3 times 6. There are 3 groups, there are 6 groups of 3. The idea of those groups is that you have repeated addition or multiplication. So c to the 16th power. And we also have y to the 5th raised to the 2nd. Means we have 2 identical groups of y to the 5th. So 5, 10. There are 10 y's. Or you just multiply. 5 times 2 is 10. Negative 2 raised to the 2nd. 3 groups of those. So I'm going to do a carbon copy, exactly 3 of these. So 1, 2, 3. So there's 3 exact copies. So what can we tell from that? Well, we have 2, 4, 6 of these. Well, what can we tell from that? Well, since we have just this number here in parentheses, I can actually do something about this. We have 6 2's, definitely. How many negatives are there? There are 6. Now, 6 negatives, that's an even number of negatives. Since there's an even number of negatives, it will end up positive. And we simply have 2 to the 6th power. Now, if you like, 2 to the 6th power, 2 times 2 times 2 times 2 times 2 times 2. That ends up being 64. Okay, number 12, trick question. Might want to put a BAM right next to this one. Remind yourself, this is important. Now, this is a little different. We have k plus 2. Now, I will say that this is exactly the same, the beginning of it. There's two groups of these. So k plus 2 to the third. We have two exact copies of that. Well, that means we have 3 6 of these k plus 2 binomials. And now, many students want to say this is k to the 6th plus 2 to the 6th. That is not correct. This is as far as we can go now. Later on, we'll be able to finish this off, but there's nothing we can do about it right now. I would go into detail, but just to give you a basic idea, to even do this 2 times would be binomial multiplication. You have to do k squared plus 2k plus another 2k plus 4. And that's just doing it 2 times. You have to do this process 6 times. We don't have the math knowledge yet to deal with this. So if we see something like that, at this point, we just simply leave it alone. Okay. Now let's try some of these. This is where it gets a little interesting. This is sort of like, if you want to think of it, this is like a distributive property. It's not, in fact, it's not even close, but this is like a distributive property of exponents. Okay? You can simply distribute this across. It's very handy. So we have 2 ways of doing this. Actually, probably more than that, but the basic ways. Now that we have this property that we can deal with, we could think of it 2 ways. We could say negative 2 to the third times x to the third times y to the third. Well, that would be, how many negatives are here? There are 3. So 3 negatives makes a negative. 2 to the third, 2 times 2 is 4, times 2 is 8. And then x to the third, y to the third. That's one way to do it. You could also say that there are 1, 2, 3 exact copies of the same thing. That's less efficient, but it still does work. Negative 2 times negative 2 is 4, times negative 2 is negative 8. 1, 2, 3 x's, 1, 2, 3 y's. And you see we come up with the same thing. So you can do it either way. Okay, again, we can distribute this 4, x to the 4th, y to the 4th, z to the 4th. Or you could do 4 exact replicas of the same thing. X, Y, Z, X, Y, Z, X, Y, Z, X, Y, Z. So we have 1, 2, 3, 4 X's, 1, 2, 3, 4 Y's, 1, 2, 3, 4 Z's. And there you go. Okay, this is an interesting one. I'm going to put a little star by this. The 2 has authority, has power over what's in his little parentheses. He does not, however, have power over this. Let me color code this for you. The green area is where the 2 has authority over. In other words, there's 2 4's and 2 b's. This yellow area here, the negative, that 2 has no authority over that. So there's still only one of those. So this is negative, and you could think of it as negative 1 times if it makes it easier. There's 2 exact copies of this. So 4 times 4 is 16, times negative 1 is negative 16. B times B is B squared. Of course, you could also think of it this way. Negative 1 times, distribute, 4 squared times B squared. So 4 squared is 16, times negative 1 is negative 16, B squared. You get the same thing either way. Now that's in stark contrast to number 16. Now the 2 has authority over all of these parts. So what I'm going to do is to break this negative 4 into negative 1 times 4. It's a trick that we're going to use several times as we go through this unit. So negative 1 squared times 4 squared times B squared. So negative 1 squared, there's 2 negative 1s. So that negative times negative is a positive 1. And then we have 4 squared is 16, and B squared. Positive 1 times 16 is 16, and B squared. And we could also do this, instead of distributing it, we could do a Xerox copy, that sort of method. There are 2 exact copies of negative 4b. Negative 4 times negative 4 is negative times negative positive. 4 times 4, 16. B times B is B squared. There we go. Okay. Now this is just a little simplifying. This isn't a general rule, but for what we're going to do, 1 and negative 1 are very easy to work with. Do those to any power. 2 to the 6th, to the 5th, to the 4th. Those are very easy to work with, the 2's. So up to 2 to the 6th would be fine. If it's 2 to the 7th, just leave it in exponential form. 2 to the 7th, 2 to the 8th. Don't worry about simplifying those. 3 to the 4th, 4 to the 4th, 5 to the 4th. Any of those, 3 to the 4th, 3 to the 3rd, 3 to the 2nd. Go ahead and do those. Go ahead and simplify that. 4 to the 4th, 4 to the 3rd, 4 to the 2nd. Go ahead and simplify those. The reason being that since we don't have the calculators to use yet, that just kind of helps to relieve some of the burden. Once we do get some calculators and we can use those, then of course, if you have a calculator, go ahead and plug it in and use that to expedite the process. All right, anything the 4th power and above, just leave in exponential form. Okay, so let's go through and see what we've got. Now, 17, I'm going to do a carbon copy, so 3x and another 3x times x. I see what I'm going to do first is to break it down. All the constants, there's the 3's, I'm going to work with first. So 3 times 3 is 9. And then I'm just going to go through. I always have to get rid of these exponents before I can combine anything together. For example, I cannot say that this is x squared until I've dealt with the squared here. When I have parentheses and an exponent outside, I have to take care of that first. So 3 times 3, 9. X times x is x squared times x again. X to the 3rd. Oops, changed font there. So 9x to the 3rd. And that's it. I'm done. Okay, let's try number 18 here. Now, we know we have 2 4's here, so I'm going to go ahead and spread these out. And again, like I said earlier, we have to check out this here. That is extremely important. I cannot combine this 4 before I take care of this. I have to take care of this first. So we're going to make 2 exact copies, 4a to the 5th, 4a to the 5th. Now, you see that there's no exponents outside here, so we can drop these parentheses. 4 times 4 times 4 times a to the 5th times 4 times a to the 5th. So we have 1, 2, 3, 4 4's. we could actually do 4 to the 4th. We get 256. And then a to the 5th times a to the 5th. Well, that's a to the 5th plus 5 more a's, so that's going to be a to the 10th. Notice this is not 5a to the 5th raised to the 5th. This is a to the 5th times a to the 5th. Big difference. Okay, real important question here. We, of course, have to take care of, when I'm looking at this problem, the first thing I see are the 2 and the 4. I have to take care of those. I also see this negative that I'm going to have to take care of right there. So let's do this. First of all, I've got the second power in front, right after the parentheses. So it's 2x times 2x. Now, how many negatives are here? There are 4 negatives. So we're going to copy exact. There's 4 of these. So 1, 2, 3, 4. Well, that's not the only way we could do it, but that's certainly one way we could do it. So we have 1, 2, 3, 4 negatives. That's going to be positive. That's going to be positive, so the whole thing's positive. We have 1, 2, 3, 4, 5, 6 x's. I see 2 to the 2nd, which is 4, times 3 to the 4th. There's 1, 2, 3, 4 threes. So 3 to the 4th. 3 to the 4th, what's 3 times 3 is 9. It's 2 threes. Times 3 is 27. That's 1, 2, 3 threes. Times 3 is 81. That's 4 threes, and that's what we're looking for. So 4 times 81 times x to the 6th, and 4 times 81, 324. Okay. Now, first thing I see here is the 2 here, the exponent. I also see this negative. You always have to be careful about those negatives. So the first thing I'm going to do is going to make 2 exact copies of x squared y. And then I've got to be careful of this. Now, there's no exponents here, so there's exactly 1 negative. So I'm just going to say negative 1 times x times y. Now, look at these. Do I have any exponents here? No. So I can drop these parentheses because it's all multiplication, number 1. And number 2, there's no exponents messing me up. So I have negative 1 times x times y times x squared times y, etc. So let's count the x's. We have 1, 1, 2, 3, 4, 5 x's. We have 1, 2, 3 y's, and the opposite of all that because of the negative 1 times. Okay. On this one, we have how many negatives? 5 negatives, and then 2 negatives, and then 3 more negatives. All these are parentheses. So really what we could do is just combine all this together. They're all the same base, so I could say the opposite of A is 5, 6, 7, 8, 9, 10. Well, 10 is an even number, so there's going to be an even number of negatives, which will make A positive. And then, of course, we just have the A to the 10th. So A to the 10th it is. And now for number 22. Again, I'm looking at this problem. The first place I go is looking at these exponents. Second thing is that I need to be careful of these negatives out front. So the first thing I have to do is the exponents outside. And then as I'm working the problem, I have to be cautious about those negatives. Okay, let's get started. So there are 3 negatives. I'm going to say that's negative 1. I'll tell you what, let's just do it this way. We'll do the carbon copies. There are 3 groups of exactly this. 1, 2, 3. 3 groups of those and 2 groups of these. So 1, 2, 3, and 1, 2. All right, now there's no exponents outside any of these, and I can drop these parentheses. Do you have to write this step down? Definitely not. I'm trying to show you just for the record. So this step, writing this down, absolutely not necessary. I'm just trying to show you more clearly. So let's count the negatives. 1, 2, 3, 4, 5 negatives. Now 5 negatives, that's an odd number of negatives. So that's going to give me a negative overall. 2 times 2 is 4. Times 2 is 8. Times 3 is 24. And 24 times 3 is 72. Now we're going to count these through. We have 1, as far as the A's, number of A's. 1, 2, 3, 4, 5, 6, 7. So there are 7 A's. We have 1, 2, 3, 4, 5, 6, 7, 8 C's. And there we go. Ready to go. This is it for Crazy Math Productions. Thank you so much. Have a good day.